Okay, so our first lesson in Math 113 is section 5.1, and it deals with angles and radian measure. So first we need to talk about what it means for an angle to be in standard position. That would mean its vertex is at the origin and the initial side lies along the positive x-axis. So I'm going to draw one of those just so we can see exactly what I'm talking about. So here we have our x-axis and our y-axis. And so let's say that our angle looks like this. So typically what will happen is there's our angle in green, and then my angle I'm naming theta. And so I'm showing you that it goes from this green line on the positive x-axis and then it stops over here on the other green line. So this would be my initial side. Okay, because that's where the arrow comes from there. And then the other green side would be considered my terminal side. So in this case, my vertex, which is this point right here, right there, that would be considered my vertex, is definitely at the origin, and the initial side does lie along the positive x-axis. So theta in this case would be in standard position. Now, theta also here is going counterclockwise. Okay, it goes the opposite way of a clock. And if it goes counterclockwise, that means it is a positive angle. Okay, if it goes counterclockwise, it is a positive angle. So theta would be some positive number there. Okay, I'm going to draw a different angle in standard position. Let me choose a different color. Let's say I do this one in red. Okay, so here's my initial side. Okay, this one looks very similar to the one that I just drew, except for when I label the angle for us, I'm going to go this direction. And so this time, my theta, my initial side, is still on the positive x-axis. My vertex is at the origin. And this time it goes the other direction and stops at that terminal side, the other red one. So in this case, theta is moving, this one is moving clockwise, not counterclockwise. So when theta is moving clockwise, then it is going to be a negative angle. And so you may remember some of that, maybe not from Math 112, but if you took a pre-cal class in high school, you may remember some positives and negatives there. Now, if I were going to ask you what quadrant theta lies in, over here where we have the green angle that creates theta, theta for this one lies in quadrant 2. Okay, and it's not because the actual where I wrote theta, it's where the terminal side is located. So in this case, our terminal side is definitely located in quadrant 2. So if you'll recall, our quadrants are 1, 2, 3, or 4. So over here where we have theta with the red angle, in this case, it is also in quadrant 2. For both of these, because again, my terminal side lies in quadrant 2. It has nothing to do where I put that actual theta symbol. It has to do with where that terminal side is. Okay, let's move on a little bit. All right. So angles are measured. The easiest way for us to think about angles, they can be measured in degrees, but they can also be measured in what's called radians. So we'll focus first on our degrees, and then we'll worry about our radians. I should have a preposition in there. Angles are measured in degrees. All right. So if I have an angle that is considered to be acute, then it's between 0 degrees and 90 degrees. That would be an acute angle. A right angle is actually equal to exactly 90 degrees. Obtuse would be an angle that's between 90 and 180. And then you may not recall this one. A straight angle is exactly 180 degrees. And so just remembering those words and being able to identify them measured based on the measure of the angle. Okay, so I mentioned the word radians. So let's talk about radians, because the other way that we can measure angles is in radians. So I'm going to add that up here. Okay, we can also measure angles in radians. So here's how we think about that. Now the easiest way for me to describe for you how is that related to degrees is for radians, we say 360 degrees is equal to 2 pi radians. So that's easy enough. Okay, 360 degrees is equal to 2 pi radians. So that means that 180 degrees would be equal to pi radians. Now pi is exactly what you think it is. That came from a circle. All right. So if I'm going to go back and forth between radians to degrees or degrees to radians, I need to be able to have some kind of method to get me there kind of quickly, because it's not always going to be 360 or 180. So let's say I want to go from degrees to radians. So the process for that is you're going to take whatever degrees you've got and you are going to multiply by pi. Anytime we write that pi, that means radians. By pi radians over 180 degrees. So for example, if I have 60 degrees and I want to write it in radians, I'm going to multiply 60 degrees by pi radians over 180 degrees. All right. So 60 goes into itself once, it goes into 180 3 times. So I end up with pi over 3, and those are considered radians. Now we won't always write the word radians, but for now we are. Okay, just like that. So if I'm going to go the other direction, and I want to say I want to go from radians to degrees. Okay, well we're just going to flip that over. We're still going to multiply, but this time we're going to multiply by 180 degrees over pi radians. All right. So if I have something like negative 5 pi over 3, because angles can be negative, we just talked about that. All right, so this is definitely in radians. Okay, anytime we see that pi, that means radians. All right, so we're going to multiply by 180 degrees over pi radians. All right, so let's just do our multiplication now. All right, so pi divided by pi gives me 1. And this word radians divides out, right? And 3 goes into itself once, it goes into 180 60 times. And we still have degrees up there, that little degree symbol. So my answer here is going to be negative 5 times 60 gives me negative 300 degrees. And I have nothing but a 1 in the denominator. So negative 300 degrees. Now sometimes it's a little tricky. There is a homework problem for you in my math lab where they make you change your radians to degrees, but it doesn't actually have pi written in it. So if I gave you something like 10 radians, now it clearly says the word radians, so we are definitely going from radians to degrees. So I'm still going to multiply by 180 degrees divided by pi radians. Process is the same. All right, so if I think about it like this, put a 1 up under that 10 radians. So here's what happens. The radians divides out, because 1's in the numerator, 1's in the denominator. But my numbers do not divide out. Okay, there's not something that divides out with that pi, so it stays there. So I'm going to multiply across. 10 times 180 is 1,800, and then divided by pi. All right. So now I have to actually, with my calculator, all right, so you should have at least a scientific calculator that has a pi button on it. You need to use the pi button on your calculator. All right, and so we're going to round to the nearest, we're going to go 2 decimal places. So we're going to actually say 1,800 divided by pi, and I get 802 and 14 hundredths. And these are degrees for my answer. So there is going to be one of those in your My Math Lab, so just be prepared. All right, let's move on. All right, so the next little idea here is now that we're able to go from degrees to radians and radians to degrees, we need to be able to draw angles. Draw an angle that represents, let's say we'll start with pi over 4. My 4 didn't look so good. Let me try that again. So pi over 4. All right, so we're drawing the angle pi over 4. So when I say draw it, I do mean that we're going to draw it on the x and y axis. All right, so there's my x and y axis. And I don't really know where pi over 4 is, but my math lab does not want you to convert this to degrees. So it wants you to figure out a way to do this without converting to degrees. So the easiest way for me to think about that is, well, I know for sure a few things. Okay, let's write down some things that I know for sure. Okay, 4 tiny little graphs. I know for sure that if I go all the way around, that's 2 pi. All the way around a circle is 2 pi. If I go halfway around the circle, that would be pi. So if I go here, whoops, if I go right there, well, that's half of pi, so that would be pi over 2. But what would happen if I go all the way down here? Okay, I went 1 whole pi, and then I went another half pi. So this would be 3 pi over 2. Okay, so these are good little things to gauge myself by. If I can figure out these 4, then it helps me with being able to draw one of these other ones that my math lab is going to ask us to draw. All right, so let's say we have this pi over 4. I want to figure out how is pi over 4 related to one of these things that I just have drawn for you, one of these 4 graphs that I have drawn for you. Well, I know that pi over 4 is half of pi over 2. Pi over 4 is half of pi over 2, because if I take 1/2 and I multiply it by pi over 2, I definitely get pi over 4. Okay, so pi over 4 is half of pi over 2. So if I look at this graph that I have right here, this one, all right, pi over 2 stops right there. All right, so that graph would have an initial side on the x-axis, and its terminal side would be there on the y-axis. That would be, in this case, theta would represent pi over 2. Okay, so if I want to go half of that, then I am going to let my terminal side be in the middle, halfway between there. So my initial side is the positive x-axis. My terminal side is halfway between 0 and pi over 2. So theta would be right here, which is pi over 4. So halfway between 0 and pi over 2. That's a little confusing, I understand. It'll take some practice. Let's try another one. Okay, let's say that we want to draw theta at 5 pi over 6. Let me change myself back to black here. Okay, So 5 pi over 6, I need to figure out how is that related to any of those that we just did. Well, I know that pi is really 6 pi over 6. I can really think of it like that. Okay, pi is 6 pi over 6. So if I have 6 pi over 6 and I subtract 5 pi over 6 from it, then that tells me where it's going to be located. So let's think about it like this. All right, if I go pi, then I go all the way to there. Okay, that would be pi, which is not what I've been asked to draw. Well, if I will subtract this 5 pi over 6, okay, then that puts me at pi over 6. Maybe it would be easier if I thought about it like this. Okay, now that I'm writing that down, I see that maybe it would be better for me to say, let's say 6 pi over 6 minus something so that I end up at 5 pi over 6. That might be the best way to think about it. So if I want to end up with 5 pi over 6, then that means I have to subtract pi over 6 to end up where I want to be. All right, remember when I start at the x-axis and I go all the way over here, I am at pi. If I subtract pi over 6, then that would end up being right here. And so my initial x-axis would be the positive x-axis. And I stop at the terminal side, so this would represent 5 pi over 6. Now that ought to be clear as pond water, which means it's probably very confusing. Let's try again. All right, let's try one more time. See if we can't make this a little clearer to you. All right, this time we're going to draw a negative angle. We'll call it theta at negative 2 pi over 3. Okay, so I need to figure out how's that related to one of those 4 basic ones that I had before, the 2 pi, 3 pi over 2 pi, and pi over 2. Well, I know that 3 pi over 3 is actually negative pi. Okay, I know that this is actually negative pi, which is one of the graphs going the negative direction. If I add to that some number, I will end up where I want to be. All right, I want to be at negative 2 pi over 3. So what thing do I have to add to this negative 3 pi over 3 to give me negative 2 pi over 3? So the solution to that would be I have to add pi over 3. All right, so let's go to a graph. And I'm going to start with drawing negative pi. Okay, I'm going to draw negative pi first. All right, I will start at the positive x-axis, and negative pi has to go clockwise. All right, that's negative pi, that direction. Now, I said we need to add pi over 3. So that means we change directions and we go pi over 3 this direction. So my terminal side will stop right there. My initial side is the positive x-axis. My terminal side stops over here at the other blue. So here is my theta going this direction, negative 2 pi over 3. So negative 2 pi over 3 is actually in quadrant 3 because that's where its terminal side is. There are some other videos that you could watch if this is really confusing. Hopefully you'll attend our Teams meeting and I can help clarify it even more for you. Okay, next idea, which also happens to be the last idea. Has to do with some more vocabulary. They're called coterminal angles. coterminal angles are two angles. Okay, they are two separate angles, but they have the same initial side and the same terminal side. And that sounds crazy. So let's look at what that might look like. All right, so I'm going to draw an angle. Okay, let's say I draw that pi over 4 that we talked about earlier. Let me make it so that you can see it very easily. My initial side is the positive x-axis. My terminal side is here. So here is my theta, pi over 4. And I am looking for an angle that would be coterminal to pi over 4. So the only way it can have it has to look exactly the same. It has to have the same initial and terminal sides. So let me just choose a different color here. I'm going to choose green. If I start at the same initial side and I go all the way around the circle, then I've gone 2 pi plus pi over 4. So now it has the same initial and terminal sides. So the pink angle was pi over 4 theta. The green angle, let's say we call it alpha, okay, just so we can name it differently. Alpha is, we went all the way around the circle and then we added pi over 4. Okay, so we have to actually do the math there to get a common denominator. So that would be 8 pi over 4 plus pi over 4, which would be 9 pi over 4. So these two would actually be coterminal angles. They have the same initial and the same terminal side. So there is a little formula for you being able to figure this out. So our little formula is found by, let's take whatever theta is and we can either add or subtract a full circle. We could do it twice. We could subtract 2 circles, and so 360 times k is just some integer, any integer. So if you wanted to go around the circle 3 times, you could go around the circle 3 times and then add pi. So if I went 3 times, that would be 2 pi, 4 pi, 6 pi, plus pi over 6. But then it's a really, really big angle. And since we know that we can also work in radians, another way to write 360 is to write 2 pi and then times k. Again, is just any number. So if you relate that to what I've just done here, our theta was pi over 4, and I added 2 pi. So I used this formula. And my k is 1. I only went around the circle once to get back there. All right. So here's something that my math lab is going to ask you to do. It's going to ask you for coterminal angles, but it may say something like your angle must be less than 360. So 9 pi over 4 is bigger than 360 because it's around the circle more than once. So it doesn't want that. So we would have to find a different angle if we were going to do it that way. We'd have to go the other direction. So maybe I should pull that down and show you what I mean by the other direction. Let's say I'll use red. All right, if I want to use the same initial side, I still have to start on the positive x-axis. But let's say I go this direction. Okay, I went in red this time. Now I went counterclockwise, right? So that's definitely going to be a negative angle. So if I started with my theta value, pi over 4, and I subtracted 2 pi. Okay, let's see where that takes me. So again, I would get a common denominator. And And so pi over 4 minus 8 pi over 4 would give me negative 7 pi over 4. So this red angle, let's say we call it gamma, would be negative 7 pi over 4. That is a gamma symbol. Kind of looks like a Y. Okay, so just because I know you guys are seeing these little symbols and you're like, what in the world? Okay, this symbol is called theta. This one that kind of looks like a fish, but it also kind of looks like an A, is gamma. I'm sorry, that's not true. That one is alpha, because it looks like an A. And then this one that I just drew that kind of looks like a Y, that one is gamma. When you look at my math lab, it'll use these symbols a lot. So I just wanted to make sure that you knew. Sometimes it will also use, it kind of looks like a B, and that would be beta. So just in case you see those symbols, they always represent an angle. Theta, alpha, gamma, and beta. All right, so let's go back to our coterminal. And let me give you a question like maybe that would be in your homework. All right, so it would say find a positive, okay, because they're going to be specific. Find a positive angle, and I told you they might say less than 360, so let's do that. So less than 360 degrees. That is coterminal. With the following, and we'll do a few of these so we can practice. Okay, so let's start with a 400 degree angle. So we're looking for an angle that is coterminal with 400 degrees. Now remember, we take theta and we either add or subtract 360 in this case because we're working with degrees. So we're going to subtract 360 because it says our angle has to be less than 360. Okay, and so that would give me 40 degrees. Oh, that was so easy. You wouldn't even have to look at the graph. All right, let's do another one. Negative 135 degrees. Okay, I've got my theta, and I'm going to add 360 because I want my answer to be less than 360. So this is going to give me 225. Okay, awesome. All right, let's try one that's in radians. So in this case, we think of this 360 as being 2 pi. All right, let's try 17 pi over 6. All right. Well, let's think about it like this. Here's the way my brain has to think about that. I have to go, okay. 17 pi over 6. If I just actually divide that, 6 goes into 17 2 times with 5 left over. So I know I've got 2 and 5/6 pi. Awesome. So if I take 17 pi over 6 and I subtract 2 pi, okay, because this 2 right here, okay, that means 2 pi and then 5/6 more. Let's get a common denominator. So 17 pi over 6 minus, we need a common denominator of 6, that would be 12 pi. That leaves me with 5 pi over 6, which is definitely less than 2 pi. And really there it was sitting there when I wrote it as a mixed number. Okay, so 5 pi over 6 would be coterminal. All right, last one. If I have negative pi over 12. Okay, if I take negative pi over 12 and I add 2 pi, again, think about getting your common denominator. So this would be 24 pi over 12. So when I put those together, I get 23 pi over 12, which is less than 2 pi, okay, because 2 pi is 24 pi over 12. So there are 4 examples of coterminal angles. Make sure that you're able to do that. So this is all the notes for section 1. I will post more notes for sections 2 and 3 at a later date, but for now, let's just make sure we understand this, and I hope to see you in a Teams meeting.